All right, we're going to begin quadratic applications, and the first one is on cost versus income. Now, the one thing about these application problems is it kind of answers that question, what are we ever going to do with this? Right? So for the next several days, including the time after your spring break, we're going to be talking about what do we do with quadratics, okay? We can talk about throwing a ball, because if you throw a ball, throw a football, kick a football, the path it takes up in the air actually follows a parabola. So that's a quadratic equation that we could use to model that. We're going to start today with what they refer to as nonlinear systems. We're going to talk to you about bungee jumping. So as we start into it, I did try to find a little clip art of a bungee jumper. Anybody in here ever bungee jumped? Okay. You've done it at the mall. Okay. I don't think I would ever have the guts. I might regret it later, but I can't imagine going to this huge, tall bridge and having somebody strap something around my ankles attached to a bungee cord and me just fall off and guarantee that it's just going to, swing me back up. Yeah. They have to. You bounce and bounce, and then they'll have to pull you back up. But all right, so the bungee jump attraction at the fair makes income. So income is made by charging a price to jump the bungee cord ride. So if we do the bungee cord ride, they're going to start us off with number 1. It says I parentheses P. Now this is function notation, but it's not a f of x. They're going to use letter I. Tell me what you think letter I stands for after you read the sentence above it. What does I stand for? I'm just asking what the letter I stands for. Income. So it says income is a function of P. Now what do you think income depends on? It's a function of what? The price. Exactly right. So it's a function of the price. I'm going to make income based upon the price that I ask people to pay me to use the ride or to go on the ride. All right, first thing it asks me to do says distribute to write a new equation. So they've written the equation out for me. They got a P in front of parentheses. What happens if you distribute? What's P times 50? 50P. So I'm going to write that on my paper. You write it on your paper. 50P. Did you write this on your paper? All right. What's P times negative P? What's P times P? P squared. And it's going to be negative P squared. Number 1 is done. If income changes depending on the price of a ticket, find I parentheses 10. All right. So if we're going to find the income parentheses 10, what does that mean? We're going to find the I, which is income, at 10, and 10 is what? What do we have in the parentheses? Price, okay? So if I charge a price of $10, can we calculate how much income we're going to bring in? Okay? Now, it's almost like you could take the 10 and you could put the 10 in here for P here and here, or you could put it into the original version of the equation here and here. Both of those equations are exactly the same thing. So I'm going to grab my calculator, and I'm going to simply type it in. That's 50 times, I'm going to use this one, 50 times the price of how much? 10. Are you doing it as I'm doing it? Calculator should be out. That's what we're doing. Everybody's practicing, pressing the buttons. Oops, I don't need to be there. I just need to be on a regular screen. My bad. 50 times the price of what? 10. Minus 10, and what are we going to do with 10? Square it. Okay, 50 times 10 minus the price squared. How much money can we bring in if we charge $10 to ride the bungee cord ride? $400. Okay, so it tells me $400. Now, describe what it tells me. At $10 per ride, income is $400. That's what it explains to me. That's what it tells me. And that looks like a sloppy 400. Okay. Okay, But having the video means everybody's going to be able to help fill their notes in. What is the lowest price that could be charged? Okay. What's the lowest price you could charge? Guys, it's an easy answer. Cheaper than that. Cheaper than that. Cheaper than that. Cheaper than that. Cheaper than that.
$0.
Zero. The cheapest you could possibly go, right, is zero. Can you go to negatives?
Yeah.
No, not when it comes.
In money, if you go to negatives, that means, oh, you're going to pay people to ride it. Oh, who wants to ride? Who wants to ride? If you'll ride it, I'll pay you $10. Boy, that'd be great. Everybody'd love that, but we're not in the money. We're not in the market. They're not in the job business to give away money. They're in the market or business to want to gain money. So the lowest price you could think about would be zero. Then it says think about it for a second and figure out what's the highest possible price that could be charged. What in the world could we charge? And you kind of have to think about the equation. Here's where we're going to use our calculator to help us figure it out. We're going to use the table, okay? So what we're going to do is we're going to use y1 equals, and we're going to use the table to help us figure it out. Okay, let's go to your calculators. I started punching it in a while ago, but we're going to go ahead and finish it now. So it's going to be 50. Now, I don't have a P, but what letter would I need to change it when I use my calculator? X. Now, the X key is up here next to the alpha, so when I press X, 50X minus X, and then the square key is a shortcut on the left. Do you have yours typed in there like I do? Everybody should have this a calculator with their equation in it. Now, we said we was going to use the table. How do you get to the table? Okay, look on the top row. Do you see above the keys? I see graph, trace, zoom, window. Above the keys, one of them says table. Which one? So it's going to be above the graph key, isn't it? So it's going to be second key, graph key, and that takes me to the table. All right, what does this mean? If I charge $0, how much money do I make? Zero. What if I charge $1 to ride it? How much do I bring in? 49. What if I charge $5 to ride it? $5 I'd make $2.25, right? Okay. As I keep going down, $6 I'm still making money. Does everybody see what I'm doing? I want us to keep going until we get such a high price that we don't make any money. In other words, you know how when the Dixie Classic Fair comes to town, the nights that seem to be the most popular is the nights when they have those, where you could buy like an unlimited ride armband, remember that? Okay? So it's kind of like if someone said,
When you're making zero, or you start going down.
okay, it's like when, what I'm trying to get across to you is, well, here's what I'm trying to get across right now. I want you to think about, if you don't charge anything to ride it, are you going to make any money? No. If you charged the right perfect price, you can make the most money. But if you overprice it, like all of a sudden someone says, it costs you $200 to ride it, is anybody or is a lot of people going to really want to ride it? So then you kind of start going back down. That's what makes this quadratic. If you charge nothing and you charge something, you start making more money, making more money, making more money. You really want to find the perfect sweet price that everybody seems to feel comfortable paying, because then the most people's going to do it and you're going to make the most money. But if you start charging too much and too much and too much and too much, pretty soon you're going to make what? Less money, and eventually what? No money. All right, so keep going down until you make the most money, and then I want you to keep going until it gets back to zero. Now, who's done this already? 25 and 50. So what you're saying is once we get to $50, we're down to what? Zero. In other words, according to that model, $50 is just way too much. If you're charging $50, you've got so much costs, or you've got not enough people coming to offset everything. So think about it and figure out what is the highest possible ticket price that could be charged. And according to our table, we know it's what? $50. Does everybody see how we saw that on the table? I looked at when I was making zero. Of course, if you don't charge nothing, you're going to make nothing. But if you charge 50, according to this model, you're not going to make nothing either. Okay. So if these numbers, whoops, if these numbers are the input, are they the domain numbers or range numbers? Because we were putting price numbers into the equation. Remember 50 times $10 price? So are they domain or range? They are domain. What you put into the equation is the domain. What you get out of it is the what? Range. So we're actually trying to connect this real world problem back to words we already know. Okay, what is the income earned at the lowest possible price? How much money did we make? If you charge 0, you're going to make 0. What was the income earned at the highest possible price? If you charge $50, how much? You're going to make 0. That's no good. So if I charge too little, I make 0. If I charge too much, I also make what? 0. Next question says, can you pick a possible price in the middle? So give me a ticket price between 0 and $50 that would make sense. 25. Now, can you use your table and tell me what's the most income that you can make at this price? All right, so we're going back up to 25. So the first thing we've had to do is we used our table on our thing to figure out, sure enough, when I go to $25, above 25, I'm making 624. Above 25 at $26, I'm making 624, but at $25, I'm making the most possible, $625. Every time I go to off the board, it does that. $625. If these are the output answers, are they domain or range? Range. Okay. All right, let's move on. We're going to use our calculator now to graph it. I want to see what this looks like on a graph. So we've already typed it in. We've already got it in our calculator, and whoops, it doesn't like when I do that sometimes. We typed it into Y1, and we let X replace what? P. We don't have a P, so we use letter X. Okay, pull your calculators out. You got them? We just looked at the table. Now we want to look at the graph. But if we just press the graph button, if we just press it, my graph is not set at a good way to see it. And a lot of times if we have a messed up graph, we go zoom 6. Is that right? Zoom 6 is a standard window, which takes you from -10 to +10 and from -10 to +10. Do I even need to think about negative prices? So for this real world example, I don't need to see negative side of X's. Does that make sense? Am I hopefully not going to be in the negative, am I going to make negative money? So I hope that I don't even need to see below here. So let's everybody press the window button. Everybody press the window button. Okay. Do y'all see where I have my standard window settings. You may have those too. You may have something different if you've messed around with your screen. Okay. Let's see if we can figure out what to type in. The domain is a set of all the X's, right? The domain is a set of all the X's. Let's talk real quick about something. The equation said I parentheses P is equal to 50P minus P what? Squared. I takes the place of what other letter? What other letter do we usually start an equation with? Well, not X, but well, I takes the place of Y, and P takes the place of what letter? X. So usually I'm doing X's and Y's, all right? For all intents and purposes, the function notation is nice to have extra information, but you don't got to have it. If you had the equation Y equals 50X minus X squared, you basically got the exact same equation as the income that we have. So when I look at the Y numbers, I'm reading income values. When I look at the X numbers, I'm reading what? So this becomes income, and these become prices, ticket prices. Okay, all right, let's go back. Who can tell me what is the lowest ticket price? X is price, right? What's the lowest ticket price? It's the lowest ticket price. How's the cheapest you could charge? 0. What's the highest ticket price we figured out we could charge? 50. That's going to end up being my X minimum and my X maximum. Okay? What was the lowest amount of money we could make if we charged nothing? $0. What we figured out was been the highest amount of money we could possibly make according to this model. $6.25. We're going to change our window settings to be those window settings. All right, now press your window button if you don't already, where it says window. Let's change those. X minimum no longer is going to be -10. We're going to change it to 0, and we're going to press enter. What's X max going to be? X max changes to 50. X scale is just how often do you want the calculator to make a mark? I'm not even going to change that. Don't matter. I can still see what I need to see if I don't change it. Y minimum. What's Y minimum? 0. 0 amount of money. And the highest amount of money, Y max, is going to be 625. Everybody good? Press the graph key. Oh, guess what that looks like? A perfect rainbow or a perfect what? Parabola. Ding, 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 yay. All right, I gave you a little box. Graph it. You sketch it. You sketch it in your box. You didn't change your windows. Change it to these numbers, 050 and 0625. Yeah. If you press zoom 6, it does change back. Okay, next thing. We all have our graphs on the screen. The next thing, what is the sign of the p-square term? The p-square term, the p-square. Go back and look at your equation, which came from the beginning. What's the sign of the p-square term that we all typed in? Let me give you a hint. There's only 2 signs. Positive signs, negative signs. Okay. So this one, this sign is negative. Does the parabola turn up or turn down? Well, it comes up, but it turns back what? Down. So if I was pouring water out of this, it would be like the bowl's upside down, the water would pour out. So that means that I am turned down. What seems to be the best ticket price to maximize income? If I want to make the most money, what's the best charge to make? 25. All right. Put your dot up here at the very center. So you're going to come over here. And you're going to go up to the perfect price. Okay. Let's put our numbers on here. What do the numbers go to across the bottom? From 0 to 50. So 0 at the start, 50 at the end. Okay. What's the numbers up the side? Y minimum on this side goes from what? 0 again up to how high? 625. So this number right here is at what number? 25. So this point up here is at 25, 625. Does everybody see how we read our screen? Okay. All right, looking at your parabola on your screen, does this appear to have a maximum or a minimum?
It has a
Maximum. So we're going to put max right here. Define what a maximum would be. What is a maximum on any graph? Highest point. Very good. So by the same token, what would a minimum be on a graph? Lowest. So it depends on what the graph looks like. This graph we are looking at has a maximum. Now the owners of the ride, I'm up to number 13 now, the owners of the ride do have expenses. Okay? They're not just going to keep all that $625. They have money too that they have to pay out in expenses. The cost related to the price is, and here's the cost equation. Do y'all see a C parentheses P? It's a C stands for cost, and the cost equation depends on the price. Okay, we're going to put this into Y2, so we're not going to take out. We're going to go to y2, and all right, go to y equals. Go down to y2. Everybody's doing this.
Yeah.
Okay. What's the equation say? 500 goes in first. 500. 500. Subtract 5p, which would be 5x. So this represents the costs. We have some costs. Has everybody got it in there? All right, trace over to one of the intersection points. Let's see. Oh, we have to graph it. All right, let's graph it. Hit graph. Do you have a second line that comes in across yours? Break even. Ding, 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 ding. So it comes across here. I'm going to do the same thing. I'm going to come up here, and I'm going to draw a line across my graph. You draw a line on your paper that shows you. Draw that line in across just like you saw on your graph. You didn't say that. Put it in Y2. Here you go. Type it into Y2. Type it into Y2. You also got to change your. Okay, you got to change it to these numbers. 0x. Not till we get finished. If I'm on the blue line, I'm looking at income. But if I'm on the red line, I'm looking at what? Cost. Okay? All right. How many times do the income curve and the cost line intersect? They intersect. Yes, they intersect. How many times? 2 times. Here's what I need you to understand. If I take a look at this graph, it's important that you understand what it means. So, bear with me for just a second. Let me grab this pink one or purple colored marker. Let's say I come over here and I'll go across the bottom edge of the graph. I'm not going to go as far as 25. Let's just say I'm back here somewhere. Maybe I'm 18, 19. Maybe I'm 20. Is everybody with me? And I go up. Do I have a point on the cost line? So let's say maybe at $19, does it cost me money to run this ride? Yes. At the same time, do I have a point on the other line? So if I charge $19, for example, if it's $19, do I also make money on the ride? Okay, let's take a look at the table. Let's go back to your thing. Let's go look at the table again. Is everybody with me? All right, second graph. I now see X, Y1, Y2. Let's review. X is the price. So at a price of $23 a ticket, Y1 is my income or cost? Which one did we do first? We talked about income first. Okay. So the first number is income. So at $23, I'm bringing in $621 of income. But how much do I have in costs? $385. Does everybody understand? I'm making money, but I'm also paying out money. I have costs. I've got insurance. I have to buy the gasoline. I have to pay my workers. I have insurance. Anything that costs money to put this ride on is going to be something I have to deduct out of what I make. Nothing in the world is free, is it? Even if you do a bake sale. Even if you do a bake sale. A lot of people will go to the store and buy the flour or buy the mix. They make the baked goods. So you may have $15, $20, but you sit there and sell the cookies or the brownies and everything you may make $50. Is all $50 money that comes to the good? Not if you spent $20 to make $50. How much money did you really and truly come out with? $30. So you had a profit of $30. Same thing here. I am making more money than it's costing me, but there's 2 times on the map when the costs and the income are, guess what? Exactly the same. All right, on your graph again. Let's go to the graph. Everybody press graph. Everybody press graph. We're going to do intersection. Trace. How many times do the two graphs touch each other? Twice. Okay, let's go back to the first one, the closest to the left. So I'm going to trace, whoops, I have a glitch in mine. By the way, when you trace, if you do the up arrow and down arrow, do you see how mine toggles between Y1, Y2? It's like, oh, do you want me to trace this line or do you want me to trace that line? You want me to trace this line or do you want me to trace that line? Go up and down, it traces and toggles. Okay, I like the straight line. So as long as you go, like, let's go closer to one side. I don't even have to be on it. I just got to be closer to one intersection point than the other. Now what? It tells you in the notes, but I'll tell you here. Second, trace. Second, trace. I'm not doing 0. I'm not down there at the bottom. I need to do intersect. That's number 5. And this is the easiest one to remember because guess what? Press enter 3 times. First curve, it was the top one, yes. Second curve, yes. Yes, yes. What does this tell me? If I charge $11.49 for the ticket, I am making $442.54. Guess how much it cost me, though? Nope, guess how much it cost me? $442, and guess what? 54 cents. If I charge exactly $11.49, I make $442, but I also have costs of what? $442. Do you understand what that says? I'm not making any money. I'm just barely making enough to do what? Breaking even. Okay, that's what we want to do. So we're going to remember that. Come up here on your graph. Pick your pencil up. Put a point right there and put $11.49. At what price do income and costs have the same amount? The first answer is $11.49. I need you guys right now. Go back to the graph. Trace to the other side and do intersection a second time, and let's see what you come up with. Trace. I'm going to trace closer to the other side. As long as I'm closer to one side than the other, I'm good. Second, calc. And which one do I calc? Number 5, which is intersect. Then I'm going to press enter how many times? 1, 2, 3 times. And it tells me the second intersection point is what? $43.50. At $43.50, I'm bringing in $282. But guess how much money I'm paying out? My cost and my income are at the exact same spot on the graph. So let's remember that. $43. Is that 50 cents or 51 cents? All right, the second point turned out to be, and I keep messing my screen up, $43.51. Shh. When cost and income are the same, are we making any money? If I bring in money and I send out the same exact, no, I'm not making any money. But this is called the what? Break-even point. These application problems require you to give some thought to what the graphs mean, what it says to you, and how you can work with it. It's not just about crunching numbers. You got to do a lot of different things. So this is, to me, they're tough because you got to take it in, you got to analyze it, and you got to spit out what makes sense as far as the answer goes. Okay, answer the next question. At any point on the income curve, is it above the cost line? Yes, it is. At that time, are we making money? Yes. So people would say the bungee ride is finally earning a, nope, profit. How would you write an equation for profit? There you go. Take the money that you come in, which is your income, that is the money that comes in, subtract the cost, which is the what? the money that you have to pay out, and what's left over is your money to keep and do what you want to with. Okay? So that would be your profit. We just solved a quadratic equation by using intersection. The two answers for price were $11.49 and $43.51. This is called a system of nonlinear equations. All right, I want to go back to that picture before we go to the next part. I want to go back to that picture. Now, when are we making a profit? Between here and here. When I'm between here and here, I am finally making a what? A profit. Okay? What about when I'm under here? What about at this point? What if I charge $5 to ride the ride instead of $11.49? What if I charge less than that? I'm not going to make enough money, right? I'm going to be operating in the hole. You ever heard anybody say I'm operating in the hole? Or I'm in the red? Shh. If you're operating at a loss, you're not making money. So right here, we are losing money. So that means I need to charge at least what? $11.49. I'll break even if I charge $11.49. If I charge $11, I'm losing money. If I charge $10, I'm losing money. If I charge $5, I'm losing money. Anything less than $1.49, I'm losing money. Okay? What if I charge $28? Am I making some money? Yes. What if I charge $30? Yeah, maybe not making the most, but I'm making money. What if I go beyond $43.35 or $43.50? I'm making no money again. So over here, I'm losing money on the upper side. So this is what I kind of need you to understand. As long as you're in between, you're making money. If you're on the left side, if you're too low a price or too high a price, you're going to lose money. Does that make sense? Okay, and that's kind of the way it is. If the Dixie Classic Fair came to town and charged everybody $75, they would make some money, but not enough people would show up perhaps for them to make the most money, because that's getting a little bit high. Okay, but if they came in and just charged $5, wow, there'd be so many people show up. They would have so much cost with the gas and the extra people to run the rides. They would come out in the loss. They would come out losing money. Does that make sense? So if you're in the business to make money, you can't charge too little, but you can't charge too much. You want to try to find that perfect sweet spot of a price in the middle that about everybody's willing to pay, where the most people will show up and pay that price. Right, Daniel?
Yeah.
Thank you. All right. This is a little bit of a long lesson, so let's go ahead and push forward. Let's start part 2. Part 2. This is totally with the calculator. It's pulling off of the idea of doing intersection, where we have a non-linear equation. What does non-linear mean? Not linear. It means not a straight line. So I'm going to see some things that curve. So here's how we do it. We're going to go back to a standard window. So everybody's going to have to remember to do what? Zoom 6 and change it to a standard window setting. Okay, we'll do that in a second. Does everybody see what I have on the left of number 20? This equation right here has x squared in it. What kind of equation is x squared? Put that up, sir. What kind of equation has x squared in it? Nope, it's not linear. Linear has x to the first in it. If it's got x to the second, it's what? Quadratic. So this side is quadratic. And this side over here has what? That's got x to the first in it. That side's going to be linear. Calculators. Okay. I'm seeing the old information. Since I know I don't need it, I'm going to go ahead. I'm finished with that last example. Let's go to y equals. I'm going to clear out what I just did a minute ago. what I'm going to do is one side of the equal. So find your equal sign. That's going to divide the problem into two parts. One side goes into y1 equals. The other side goes into y2 equals. So I'm going to graph each side in a separate place. Everybody good? Okay, so on the left, that goes in y1, x squared minus x plus 3. Do that one. Okay, what goes in y2? 2x minus 1. 2x subtract 1. Now, we said we do not need those window settings that we just used because we changed those like 0 to 50 and 0 to 625. We won't need those big numbers. Hit the zoom key and hit 6 and it will change it back to what we need. Okay. These are going to be some that you do not have to work out. You're going to see the answer on the screen. Do these two lines even intersect? No. Okay, sketch it out on your paper. This one has what? Why do you think it has no real solution? They do not touch. They do not intersect. That's number one. Nothing to work out. I'm going to get my answers by intersection. I'm ready to do number two. Now, this is called nonlinear. Do you see a curved line? Did y'all see the parabola? The first one came in as a curved line. The second one came in as straight. This is called a nonlinear system. I'm going to be graphing two or more equations and trying to find out where do they cross. Okay, how would I do the second one? Everything to the left. Find your equals and let that split your problem into two parts. Everything to the left is going to go in one equation. I'll put it in y1. And everything on the right is going to go, guess where? Into y2. Okay? So let's do this second one. We got our answer to the first one already, so clear that one and clear this one. X squared minus 3x plus 2. And I'm going to go to y2 and type in what? X subtract 2. Is everybody ready? Now, I already did zoom 6. You technically only have to do that one time. And after that, it will always remember that and go back to the same press graph. Do these two touch? How many times does it look like they touch? Once. Guess how many answers I probably have? One. Do you all remember what we said about the one solution answer ones being the hardest for the calculator to calculate? It may sit there and spin its wheels. What if it tells you the answer is 2.999999? What are you going to call that? 2.999, you'd call it 3. All right, so let's just see. So it looks like, I'm going to sketch it. Sketch it out on your paper. It's all I'm asking you to do, since you're not going to have to work it out. Your calculator's going to do the work for you. All I ask you to do is just sketch a picture. So it looks like it comes and touches one time right there. So it looks like I have one intersection. Okay, let's go to trace. Do y'all remember how to do this? Trace. Trace over as close as you can. And then we're going to do what? Second. Calc. Which one are we calculating? Intersect, which is number 5. And then how many times do we press enter? 1, 2, 3. This is the one that takes a long time. Notice it's working. It's working. Oh, 1.99999999. We're going to call that what? 2. Okay, so one intersection means what? One answer, one solution, and x is going to equal 2. So that's where they intersected, was at 2. Does everybody remember how we do with the 2 answers? Or one answer? So far, so good? Are y'all picking up on how to do intersection? Okay, let's do the third one. And then this will be the all of our new stuff, and after that, we're just going to practice. Okay. Find the equals. That splits your problem. Everything to one side goes in what? Y1. Everything on the other side goes into Y2. All I ask you to do is sketch a picture of it on your graph. Okay. Y1, I'm going to clear it out. Clear that one out. 10x squared minus 28x minus 39. 2x plus 1. Anybody looking at it yet? Okay. When I graph it, oh, there's my first one. Oh, there's my second one. How many answers should I be getting this time? 2. So we're going to sketch it out. This one's going to come really far down low, but all I'm really seeing is that top half, but I am seeing it come in here kind of like that. I have 2 solutions. How do you get your answer?
You gotta hit trace.
You got to hit trace. Okay. I'll let you guys work on that. Okay. Go to one at a time. Hit trace. Now remember, when you hit trace, you can go up arrow, down arrow. It's going to trace Y1 or it's going to trace Y2, whichever line you want it to trace. It doesn't matter. Go close to one side. I went to the left-hand side first. You could have went to the right-hand side. It doesn't matter which one you do first. Second what? Second, trace. Which one do we pick? Number 5, and then we press enter, enter, enter. What's my first answer? Did y'all get -1? Okay. First answer, x equals. I hate when I do that. All right. X equals -1. What's my second answer? I bet it's a positive number because it looks like you come positive. What'd you get? Positive 4. So we do sec trace. I'm going to trace the second line. I'm going to go up to the closer to the other side. Second trace, don't even really have to be right on it. 5, intersect 1, 2, 3. Sure enough, it takes me to the second one, and the answer is 4. Okay, we'll stop there and let you finish working on the rest.